Hey guys, welcome back. Sorry to do so many video lessons, but I think this will be really good to get you a jump start. Goal 4, I can determine real world domain and range. That is something that comes up over and over again on both the STAR and our CA. So I am very excited to get started on this one. So we're talking about discrete here, and it gives me 1, 2, 3 examples of discrete scenarios. So let's read the first one. To find C, the total cost of an order of DVDs from a certain website, the equation C equals 20n plus 5 can be used, where n represents the number of DVDs ordered. Okay, so I'm starting to think, okay, so cost and number of DVDs. John is looking for something to do on a Saturday night. He finds that tickets to a concert cost $20 each. The function y equals 20x will represent how much he spends on x tickets. So, okay, good. For Saturday's debate tournament, Sarah ordered 3 cookies for each student participant. The relationship can be expressed by the function C equals 3s, where s is the number of students. Okay, so why are these all categorized as discrete? What do they have in common? So if you want to think back to your notes on discrete variables way back on early last week, we can think about what discrete means. Discrete means separate and individual is how we said it. Another way to think about it is discrete means that your variable or what's changing, we'll talk about that in a second. Variables are whole numbers. Another way to think about this is you can count the object. Another way to think about this is that you have you can try and think of a way no in between values is kind of what I would say. So for example, we're thinking about DVDs. Can you have a half DVD? No, right? You can have something like 1, 2, 3, etc. DVDs. Same thing with tickets. You can't split a ticket in half and give it to 2 people. You have 1 ticket and that's for you. You can't split it up. Same thing with number of students. We can't really have a half student or a 3/4 student. You can count them up 1, 2, 3, 4, 5, 6, blah, blah, blah. That represents a discrete situation because I can count them up. There's no in between the values or number of students of 1 and 2. There's either 1 student or 2 students. So let's think about continuous. So for a car traveling at a speed of 50 miles per hour, the relationship between the distance traveled and the time traveled is described by the function d equals 50t. So we're thinking about that time, that kind of relates to my age example, right? So if you're a certain number of years old, you're not just magically 2 minutes old one day and 2 minutes old 1 minute and 3 minutes old. We have to keep thinking about seconds and time like that, right? So let's think about this one. The amount of force exerted on a rubber band impacts the distance that it can be stretched. The function d equals 5f can be used to determine the distance d for a force of 5 pounds. I'm not going to go too much into this example. This is a physics problem. But pounds, right? That's not just 1 pound or 2 pound. You can be 1.5 pounds, 1.25 pounds, and then keep going down and down. Lastly, you are pumping water out of a flooded basement. The function A equals 6,575 minus 50m represents the amount A in gallons of water remaining in the basement after m minutes. Once again, that time is always continuous. That's the first thing I'm going to write down. Time is always continuous. But remember that continuous functions, they're on a spectrum. That means that there's R in between values. So it's also something, you can't count them up. So you can't count them. They're separate. They're running on a spectrum. Okay. We're going to fill in these blanks at the bottom. It's going to take a little bit, but it'll be okay. So when determining the domain of a real-world situation, we first need to identify the independent variable. In a function, the independent variable is the blank, or commonly seen as the blank. So we can see in a function the independent variable is the x value. And I'm trying to figure out what we can put in that blank. So in a function, the independent variable, what did I want you to say yesterday? Is, I'm going to say the value you change. We'll talk about this. I'm going to say actually value manipulated. The independent variable is the value manipulated. This means that that's the value that you change in order to change your output. The independent variable, we're actually going to switch that to value manipulated. Another thing we could say there is input. So it's the input, or again, we call inputs x values. This is probably the more important one. So if the independent variable can only be, we're going to say whole numbers or certain numbers, the situation is classified as discrete. If the independent variable can be a fraction or a decimal, we're actually going to say many fractions or decimals, right? Because I could have an example where maybe it's discrete because it's only at something like 1.5. But we know that if it's continuous, it could be many different fractions or decimals. Then the situation is classified as continuous. So again, remember, you